Like gaming, that's awesome. Dance and art, welcome Erica. Hunting and fishing, love it. Gaming and exploring. I'm not sure why all your math teachers have the last name Smith. I do know that there are a lot of people in the world with the last name Smith. So, Mia, gaming and drawing. Oh, you like fishing too, Zach? Okay, great. Yeah, you didn't have to pick from like what's over here. Art and gaming, chess, video games and reading, fun, baking, chess and gaming, lots of gaming. Watching things and doing nothing. Me too, Asha. Reading and baking. Okay, I like to bake too. Hanging out with friends, cooking and reading, gaming, art, playing the guitar. Oh, electric guitar. Knitting, that's very cool. Chess, video editing, music, writing, retro TV, bike riding. Cool. Games, guitar, video games, music. Awesome. Y'all have some really unique and fun hobbies. Chess, art, playing piano. Love it. A lot of guitar players in here. Sleep and eat. I feel you there. Also play the keyboard. That's really awesome. Cool. Well, thank you so much for sharing your hobbies and interests with me. I do appreciate that. My hobbies would include anything like playing sports or just being outside. And I like to cook and bake and try new restaurants. Big fan. And I like to watch sports. You like to golf. I wish I was good at golf. I'm not very good, but I want to be. So maybe someday I'll have the time. Zach, sure. Let's see. Okay, there you go. I think you're good. Can you talk now?
Yes, can you hear me?
Yep.
So I have a lot of hobbies, but I don't get to do most of them often. I really like fishing. I really like fishing. I like hunting. I like exploring, and I like gaming. But there are a few others. I do like going to new restaurants, but one of the restaurants I really love is Olive Garden. Their breadsticks and salad are amazing.
Agree.
I also like to go on boat rides, like not like just calm ones. I like to
Yeah,
speedboats and stuff.
that's fun.
Yeah, one time I went on a boat ride on Canyon Lake with my uncle and his wife, and my mom and dad, and me and my brother. Well, one of them. And we had that thing that you drag behind your boat, and it has handles, and you grip on while the people
Oh
on the
yeah,
boat
like
to make you
a
fall off.
tubing.
Yeah, but it wasn't really a tube. There was nothing you could get into. You just had to hold on to handles.
Oh
It
wow.
was
Okay.
it was
Yeah.
a giant blow up thing, and my 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 mom and my uncle's wife were on the boat. Well, technically, my kind of aunt, my mom and my aunt were on the boat, and they were slamming us into the waves that was created by the boat. And
Oh,
I
how
was the last
fun.
one on. I was the last one on. Me and my brother. Well, my dad and my brother fell off. I was the last one on. Then I slammed into like a really big wave made by the boat, and then I fell off, and my back literally water planed on the water, and I was skipping.
Wow. That I actually do know that when you fall off into the water, it can be like pretty intense. Pretty you can get a pretty
Yeah,
significant injury, I guess I should
yeah.
say.
Whenever I stopped, I was just waiting there, thinking, "Are they gonna come back?"
Did they leave you in the water for a while?
No, they turned around, but they kind of kept going for a little bit.
That's funny. Alrighty. Well, while we have the chat open for another minute, I want you to look at these two tables, and you can tell me on the mic or in the chat, what do you notice is different about these two tables? You can say anything that sticks out to you, and then we're going to kind of start our lesson, and I will show you what I was hoping you would notice. So, what do y'all think? rate of change. Great. Yeah, Amara, you're totally fine. Go ahead. Okay, Asha, good. Okay, so table 2 has a repeating x value, x factor in a different y.
Okay, so table 2 is not a function. Table 1 is a function.
Okay, that is exactly what we're going to talk about today. So Zach was right on the money. He said table 1 is a function. Table 2 is a relation. Okay. And we want to talk about, okay, well, why is that? And the short answer is that table 2 has the same number in x. It repeats. So the first time that we see it, -1 goes to 4. Then we see it again and it goes to 6. So because there are 2 x values that are the same number, this is not a function. Okay, so that's kind of like the quick answer, but we're going to spend the entire lesson today talking about how to determine if something is or is not a function. So let's go ahead and talk about relation versus a function and what is the difference. So a relation is a rule that pairs each element in one set. So element meaning each number in our graph or our mapping or our table. So it's going to pair each element in one set called the domain with one or more elements from a second set called the range. Another important thing to note here is that domain is x values, range is y values. So it's going to take one value from the x and pair it with one or more elements from the y values or the range. Here's the difference between the relation and a function. A function pairs each element in one set, called the domain, to exactly one element from the second set, called the range. So a function takes an element from x and pairs it to only one y value. Okay? Let me show you how that looks in a mapping. These representations down here are called mappings. So this first one is a function. So we have this x value of 1 and it goes to 5. That's it. We have number 2, the value in the domain, 2 goes to 6, 3 goes to 7, 4 goes to 8. So we don't have any x values here that are repeating, okay? Each of these x values only goes to one number in the y values. So this middle one is not a function. Why is it not a function? Well, because of this number 3. 3 goes both to 7 and to 8. So because this goes to 2 different y values, it is not a function. What do you think about this last one? Function or not a function? I'm going to put up a poll. Whoops, where is it? Green for if you think it's a function, red X if you think it is not a function. We're like evenly split, 50-50. This is kind of a tricky one. That's why sometimes these can get a little tricky. Hang on, Zach, just a second, okay? All right, I'm going to give us 10 seconds. I put the room chat away, Richard, right now because I didn't want it to be distracting for everyone. It's not just you that's muted. All righty. So most of you said yes function. About a third of you said not a function. So this one is a function. Green check is a function because 1, the number 1 goes to one value in the y. 2 goes to one value. 3 goes to one value. 4 goes to one value. So because I do not have 2 lines coming out of one of these numbers, Zach, I see you. Just a second, okay? Because I do not have 2 lines coming out of the x value, the domain. The domain is what we want to look at when we're talking about, is it a function or is it not? We want to look at the domain. If there is a repeating value, the same number 2 times, or a line coming out 2 times, that's when we know it is not a function. Okay. All right, Zach and Richard, do y'all have questions?
I was going to try and explain, but okay, you did.
Okay. Richard, do you have a question?
Yes, just wanted to comment that number 3 could not be a function. If we had a longer list of numbers, then there could be one on there that, well, the same x goes to 2 different y's.
Well, yes, but this one is a function because when we represent a function or a relation in a mapping, we are assuming that every number in that relation is listed. So, sure, there could be some invisible number here that someone forgot to list, but that in itself would be an error. So we're assuming that they listed all the possible numbers. Alrighty, so today we're going to define relations and functions. We're going to practice identifying whether something is a function. And then if we have some time, we're going to evaluate some functions. So let's talk about, this is just kind of like a warm-up. Show me what you know. So if you would like to write an ordered pair for me, remember an ordered pair is the x value first, then the y value. Please raise your hand and I will give you whiteboard tools and tell you which one you can do. Hey, Maddie, that's great. Just send me an email, okay, about that. All right, so Zach, I'm going to put you here. Richard, you're going to do B. Give me just a second to give you tools. I, Tana, C, Jonathan, D. Does anyone else want to try to write out the ordered pairs? Oh, awesome. Adrena, thank you. And Ben, awesome. Thank you. Okay, let me get y'all whiteboard tools. Oh, Ben, did you not want to do it? Sorry. Ben, you do. Okay, cool. All right, so if you are not writing it on the board, then you should be writing these down on your own paper and see if you can beat everyone on the board. Trina, there you go. Aitana, there you go. Jonathan, there you go. And Ben. All right, so let's check and see how they're doing. For the point A, Zach said that point is 0, 4. He is absolutely correct. So we're going to start at the origin, 0, 0. The x value is if we're moving left or right. And then how much we go up or down is the y value. So we're not moving left or right. So that stays at 0. And we went up 4. Good job. For B, we've got -6, 0. Excellent. For C, we've got -4, -4. Awesome. For D, we've got -2, +6. Good job. Zach, don't draw on the board, okay? For E, we have 5, 2. Very good. And for f, we have 2, -4. Yeah, you drew a little arrow. Let's just rewrite it. 2, -4. Good job. Yay. Y'all did great. Good work. All righty. So now that we know how to write these ordered pairs, we can also represent a function or a table many different ways. Okay. You're welcome, Ben. So I'm going to show you how we can do this because what we have here is a mapping. Okay. So we can take this same relation and write it as a table, as a set of ordered pairs, and we can graph it. Okay, so right now, if you are looking at that mapping, I want y'all to tell me in the poll, what do you think? Function or not a function? Okay, most of you are saying not a function. That is exactly right. Very good. So it is not a function because this one has two different numbers that it goes to. So 1 is being used 2 times. Okay, so therefore it is not a function. But let's go ahead and write this out. We're going to start by writing it as a table. So in the table here, these are all my x values on the left. I'm going to write them out. So I would have -2, 5, and then I would have 1 2 times. So -2 pairs with 7. So when x is -2, the y value is 7. When x is 5, the y value is 4. When x is 1, the y value is 3 and 0. So now we can go from the table to a set of ordered pairs. So now I just write these as ordered pairs. So I have -2, 7, 5, 4, 1, 3, and 1, 0. That's supposed to be a 3. It's a -2. Here we go. Okay. So as you can see, we are able to determine if something is or is not a function when it's given to us as a mapping, a table, a set of ordered pairs, and now finally a graph. So these are ordered pairs. So we're just going to graph them where they go. So I would go left 2 and up 1, 2, 3, 4, 5, 6, 7. That would be like up here. Okay, then I would go to 5, 4, 1, 3, and 1, 0. So if I was just looking at this graph, I would say, oh, look, these are both on that same x value of 1. Therefore, it cannot be a function. Okay, so we've got x values. X values cannot repeat. Okay, if it's a function, they cannot repeat. So let's talk about independent versus dependent variables. You've probably used this in science before, but the dependent variable is what is going to change in response to another variable. So this is going to be our y value. The dependent variable is your y value. So we change x, and then we get a new y value. Okay, so that means our independent variable, which determines the value of the dependent, that's going to be our x. We put in a new x, we calculate it, we get a new y value. Okay, so if we had this problem, y equals 2 times x minus 3, we're putting in a number for x. Let's say we put in 1. When we change the x value to 1, y becomes negative 1. Okay, so let's talk about how we would use this in the real world. I'm going to open the chat for just a second. Does anybody have a job? And if you have a job, tell me what your job is. Okay, doing your chores. Okay. Okay, so let's do this. Let's pretend that you all just got hired on and you are gonna mow grass. You get to mow grass. Congratulations, you just got a fake job. So you're gonna mow grass and you decide that you're gonna charge $30 per yard. Okay? So your equation would be y equals 30x. So the independent value here is our x value. We would not, although I don't know, maybe you would, but realistically, you wouldn't say, hi, I will come and mow half your yard today, right? You're going to mow the entire yard. So your independent value, your domain here, okay, is going to be whole numbers. 1, 2, 3, 4, right? It's not going to be numbers 1 through 4 because you're not going to mow 1.71 yards. You're not going to halfway mow somebody's yard. I hope you wouldn't. Okay, so your number of money that you make, y, is dependent on how many yards you mow. Okay, so if you're getting confused on which is the independent, which is the dependent variable, you can think of this example. Think of the real world and just say, okay, how much money I make depends on what? Or my y value, is that what's changing? Or is that what's changing because I'm changing something else? All right, so now what we're going to do, you're going to tell me if something is or is not a function. I'm going to cover them all up, and then I will just reveal one at a time. Okay, so we're going to start with the one on the top left. It's a graph. So I'm going to open up the room chat, and you're going to tell me yes function or not a function. If it's not a function, you're going to tell me why it isn't a function. So let me open up the room chat. We're looking at the only graph that is still showing. So in the room chat, function or not a function? And if it's not a function, tell me why it is not a function. You can tell me what value is repeating. Good, you're right. It is not a function because at this x value of -2, if I were to list all of these values out, this -2 would go to 2 different y values. So this one is not a function. All right. What about this one? function or not a function? And if you think it's not a function, you're going to tell me why it's not a function. Good. This one is a function. So the first thing we should be doing is checking our domain, which is the x column. And we're saying, okay, -1, 1, 2, -2, -3. Do any of those values repeat? They do not. So since they do not, that means it is a function. Yes, Richard, what's up?
In regards to what you said a few seconds ago about nobody going to mow a non halfway. Okay, hear me out. I'm going to mow your non, but I'm going to do the front yard today and the backyard tomorrow. And since I'm having to work 2 days, it's going to be costing you extra.
Well, then I am not going to hire you.
2 days, you already signed the contract.
Well, that's not really how it would go. But I understand what you're saying. Alrighty, let's look at this one. This is a mapping. What do you think? Function or not a function? And if it's not a function, I want you to tell me why. Good. It's not a function because 8 has 2 numbers coming from it. Very good. All right, let's check out this set of ordered pairs. What do you think? Function or not a function? Excuse me. Yeah, you're right. It is a function. We look at only the x values. Okay. We're just looking at x values. 5 doesn't repeat. 1 doesn't repeat. 2 doesn't repeat. Thank you. 7 does not repeat. So this one would be a function. All right. What about this? So we haven't talked about this just yet, but when you get a graph, the way that you determine if something is a function or not is by using what's called the vertical line test. So what you would do is, I'm going to draw like a straight line right here, okay? You can use your pencil, you can imagine it in your mind, but you're basically going to take this line and move it across your function. If at any point this line touches my function or relation, if at any point it touches it more than once, it's not a function. So it has to pass the vertical line test, meaning it only touches the function one time. And you are right. This one would be a function. All righty. What about this one? Again, we can use our vertical line test here. So we can put it on this x value. Only touches 1 point. Only touches 1 point. Only touches 1 point. Only 1. Only 1. Only 1. Only 1. So therefore, it is a function. All righty. What about this mapping? Function, yes or no? Be careful on this one. If you said no, tell me why it's not. Yeah, good. So this mapping's a little tricky because before we would normally have this -6 and it would just have 2 lines coming from it. But instead, this time they wrote it out 2 different times. But it's still, because that value is repeating, this is not a function. All righty, let's use our vertical line test. What do you think for this one? Function or not? So immediately right off the bat, you can see I am touching the function here and here. So not a function. Alrighty, what about this one? Function or not a function? Use your vertical line test again. Good, y'all are really getting the hang of this. Good, not a function. We got 3 more. Pay attention to where your x's are, your domain. Good. This one is not a function because 18 repeats. Very good. All right. What do you think about this one? Good. I'm glad you think this is easy. Yeah, good. Not a function because we have 2 and 2. All right, last one. Function, yes or no? Good. This one is a function. Very good. Y'all did awesome with that. Okay, so now we're going to talk about evaluating functions. So this is my x value. This is my y value. What this is saying is if I plug in 2 for x, what is the y value? So if the domain, the x value is 2, what is the range? This range would be 7. I just used the table. All right, so let's talk about how to do this on a graph. So again, -1 is my domain. Okay, that's my x value. So if I go to -1 right here on the graph, I come down, where do I hit my function? The y value or the range is going to be -4. Very good. Okay, Angel, why don't you do this one? Is there anybody else that wanted to volunteer that has not yet, that did not get a chance to do it? If you already got a chance to do the whiteboard, don't raise your hand. So, oh, good. Alan, will you do this one? I'm going to just write Al because you have the same initials as Angel. So, Angel, yours is kind of tricky. You'll have 2 values, so you might need to write a second ordered pair here. Oh, no, you're fine. You're fine. Sorry. You're right. That's not the one I was thinking of. You did it good. What do you think? Did Angel get it right? 0. Good. 0, 3. Very good. And Alan said 3, 2. Very good. All right. So we can evaluate now in a mapping. We can evaluate from a graph. Now we want to evaluate by being given an equation. So something important I want to make you aware of is that this f of x is the same thing as y. So for instance, on this one where you see f of x, that f of x is really y. This is y equals x. Okay? So the reason we use this f of x notation, it's called function notation, because when I write it as f of x instead of y, I can now plug in the number here and know what I want to put in for x. So for instance, this first one, f of 15. So that means I'm going to rewrite it and say, okay, f of 15 equals, and what was my equation? Well, it was just x. So anywhere there was an x, I'm going to put that number 15. So this one was easy because it's just 15. But let's try this next one. So we have g of n equals n plus 4. So we've got g of 7. So now I'm going to write g of 7 equals, remember, anywhere there was an n, I'm now putting a 7, equals 7 plus 4. 7 plus 4 is 11. So g of 7 is 11. Alrighty, I want y'all to try this one right here. H of x equals 3x plus 5. What do you think? What would h of 2 be? H of 2 would be what? We're going to write it in. H of 2 equals 3 times 2 plus 5. So put in the chat, what would that be? Put it in your calculator. Anybody? Good, Erica. Good, Liv. Yeah, there we go. 11. Good. All right, let's try number 4. Okay, guys, let's talk about math, okay? Otherwise, I'll have to take the chat away. All right, so R of 8 is 1/2 times 8. So half of 8 plus 1. What would we get? That's okay. Don't worry about it. You're good. It's an 8. So half of 8 is 4. 4 plus 1 is 5. Good. And then f of 1. So if we're evaluating this function at 1 times 1 is going to still be 0.3978. I wish it was 2. Me too. Okay, I want to make sure that we're getting to our a little bit tougher problems. So here we are. We are going to now talk about briefly what is domain and range. We're going to have a whole, we're going to spend 4 days on domain and range at the end of the week and going into next week. But let's talk about this problem. So Marisol is buying cupcakes for her daughter's birthday party. She will need at least 2 cupcakes, but no more than 8. Cupcakes at the local grocery store cost $3 each. The function P of C equals 3 times C. This represents the price of buying cupcakes. What is the domain and range? Okay, so let's first remember, tell me in the chat, is domain X values or Y values? Okay, good. So I'm going to make a little note over here. So domain is X values. Range is Y values. Okay. So if this is her function, P of C equals 3 times C, the smallest number of cupcakes she's going to buy is what? No, the smallest number. She's going to buy at least 2. Okay, so what I'm going to do is plug in 2 for C. Okay. So when she buys 2 cupcakes, it costs her $6. Okay. 2 cupcakes is the domain. The range, her price now is $6. The most amount of cupcakes she's going to buy was 8. So the price of 8 cupcakes is 3 times 8. The price of 8 cupcakes is $24. Okay, so remember, domain is your X values. In other words, it's your independent or your input. So that's the thing that changes. My domain is it's not going to be from 2 all the way to 8, right? Because she's not going to buy 2.5 cupcakes. she's going to either buy 2, 3, 4, 5, 6, 7, or 8. Okay? Her range, the cost, if she buys 2 cupcakes, it's $6. 3 would be $9, $12, $15, $18, $21, $24. Okay, so what you're doing is you're just listing out, okay, what are her prices? Domain is the number of cupcakes. What are all the possible number of cupcakes she could buy? She could buy 2, 3, 4, 5, 6, 7, or 8. So if she buys 2, 3, 4, 5, 6, 7, or 8, what are her possible Y values or the range? 6, 9, 12, 15, 18, 21, or 24. So this is kind of like next level where we're going to be going a little bit higher thinking. So you have to do some math on your own to get the answer. Alrighty. So what I want you to do is you are going to send me a private message. And you're going to say for number 1, yes function because of this. And then put number 2, what is the value of f of -2? So you're going to plug that in your calculator. Okay. Don't forget to tell me why it's a function. Once you send me your message and I say your name, then that means you are good to go. And I'll go over this in 3 minutes. So. Good, Ariana. Now tell me number 2. Good, Jonathan. Now tell me number 2. Good, Ben. Angel, check again. Good, Mason. Yes. Angel. Adrena, check your math again for number 2. Anya, not quite. Yes, Antoine, you are great. Got it. So if you're stuck on number 1, let's take a look at our X values. I have 4 to 5, okay? 8 to 5. That's okay because Y can repeat. X cannot. So X has 1, 2, 3, 4 numbers and only 1 line coming out of each. So X is a function. 1 is a function. For number 2, f of -2 means I'm going to plug in -2 for X. Okay, remember, I do exponents first. So -2 squared is the same thing as -2 times -2. -2 times -2 is a positive 4. So I would get 2 times 4 minus 1. 2 times 4 is 8. 8 minus 1 is 7. All righty. So that is all that I have for you today. I'm going to go ahead and